We're going to look at pollution caused by burning fuels. Okay, now the first thing we're going to look at is incomplete combustion. Now, when you burn fuels, you need oxygen, and you usually get carbon dioxide and water as the only products. But if there's not enough oxygen about, then instead of carbon dioxide, you can get carbon monoxide or even solid carbon. So let's have a look at the equations for that. Let's just take the simplest hydrocarbon. Let's take methane, which is CH4. Now, so CH4 is going to react with oxygen to give us carbon dioxide gas and H2O. So to balance that, we've got balance for the hydrogens. That means we need 2 waters there, and that means we are going to need 4 oxygen atoms on the right hand side, so we need 4 on the left, so we put a 2 there. So if we have 2 moles of oxygen for every 1 mole of methane, we get complete combustion and you get carbon dioxide and water. However, if there's not quite enough oxygen, then what will happen is you don't get carbon dioxide, you get carbon monoxide, and you get water. So let's see how much oxygen is needed for that. We'll balance that equation. 1 mole of methane is going to give us 2 of water. Now that means we are going to have 3 atoms of oxygen, so that means I'm going to have to put a 1.5 in front of that oxygen there, and I prefer to do that rather than double everything. So we can see if we don't have 2 moles of oxygen, we have slightly less. When you've got 1.5 moles of oxygen for every mole of methane, we won't get carbon dioxide, we'll get carbon monoxide. Now if oxygen is even in shorter supply, we won't get any carbon monoxide, even we'll get carbon, state symbol as a solid, so you get tiny particles of carbon, which we'd probably call soot. Okay, and you'll get H2O, and now to balance that I needed 2 there, but you've got 2 atoms of oxygen, so yeah, if you only have 1 mole of oxygen for every mole of methane, you won't get carbon monoxide, even you'll get soot. Now if you've got any less moles of oxygen, then what will happen then is you won't get hydrogen. With the hydrogen, what will happen, some of the hydrocarbon will remain unburned. Okay, so these 2 are incomplete combustion. And the problem with there's problems with these. First of all, carbon monoxide is poisonous. Okay, it binds to hemoglobin and it prevents the hemoglobin carrying oxygen around the body, and so it will kill you. And it's an odorless gas. And so if you have a central heating boiler or something which isn't getting enough oxygen to it, it's producing carbon monoxide, it's very dangerous because that can build up in the house and it makes you feel sleepy, and you fall asleep and then you end up being poisoned and killed by it. Okay. And car engines also produce quite a lot of carbon monoxide. So diesel engines and petrol engines all produce that. And catalytic converters get rid of some of it, but not all of it. Okay, so and that is poisonous. Right, what's the problem with this product, the solid carbon soot? Well, it makes particulates, and they irritate the lungs and cause breathing difficulties. Okay, and that is becoming increasingly aware that they do cause a lot of damage. So you can't see these particulates in the air, but in cities they build up and they're produced in quite large amounts by car engines, particularly diesel engines. And they also cause this phenomenon called global dimming, which means some of the sunlight is absorbed by these particles. Right, let's look at other problems then. This is particularly from diesel engines and petrol engines. We're going to talk about oxides of nitrogen. Now, nitrogen, of course, is 80% of the atmosphere, and it's very unreactive. It's very unreactive because you've got a very strong triple bond there between the nitrogen atoms. That's about 946 kilojoules per mole. And that is about 3 times stronger than most bonds. So the activation energy to break that is very high, so it tends not to react. However, in a car engine, in an internal combustion engine, because of the high temperatures in petrol and diesel engines, it will react with oxygen. So it won't, if you just burn gas in a gas cooker or something, the temperatures are not high enough to react. You don't produce any oxides of nitrogen, but in an internal combustion engine, it's different. It is high enough. And what happens, nitrogen will react with oxygen in the air, and it can produce a variety of oxides of nitrogen. It can produce, they're sometimes called NOx like that, because X can be a different number. So you can actually have, that's nitrous oxide, or X would be equal to a half there. Or you could have nitrogen monoxide, X is equal to 1. And you can also have nitrogen dioxide, NO2. They're all produced. But what the problem with all of those things is, in the air, they all react with oxygen and water to form this HNO3, which you'll probably recognize that is nitric acid. So that causes acid rain, which is obviously damaging to aquatic life and things, but it also it causes respiratory problems. So diesel and petrol engines produce nitrogen oxides, and they lead, they cause breathing problems. Right, there's just one other pollutant we need to talk about, which comes from burning fuels, and this is sulfur dioxide. So if you like sulfur with an F. Right, so sulfur dioxide has the formula SO2. And what happens, it's a gas. It will react with oxygen and water to form sulfuric acid. And that, of course, causes acid rain. Sulfur dioxide also causes breathing problems. It will basically form sulfuric acid in your lungs. Right, now where does it come from? Right, all fossil fuels contain small amounts of sulfur as compounds of sulfur, because fossil fuels come from living things. Living things all contain sulfur. It's present in proteins, present in other molecules, so they will contain small amounts of sulfur. The particularly large amounts of sulfur are found in coal. Smaller amounts in crude oil and petrol and so forth. But when you burn any fossil fuel, what happens? The sulfur in the present in compounds, it won't be as sulfur as the element, but I'll just write it as S there, react with oxygen when you burn it, and it will form SO2, and that will go on to produce acid rain and cause breathing problems. So we've looked at the following pollutants there, all caused by burning fuels. We've got carbon monoxide, poisonous, is a gas. Incomplete combustion causes that. We've got carbon particulates, they cause breathing problems. We've got oxides of nitrogen, cause acid rain and breathing problems. And we've also got sulfur dioxide, that causes acid rain and breathing problems.